Okay, so we're going to start with our initial fracture here. Okay, one thing I want to do here is just change this detriangulate to no polygons. You see we get a bit of a different mesh, you know, it will just stay as triangles basically. And I think it's just a good idea for since we're going to subfracture this later on. So what we want to do is I'm going to scatter some points on this first of all. I'm just going to do 20 points. Well, we just want them on the surface. Well, we could either scatter them onto here or just set the position to 0. Sorry, at p dot y. Sorry, set the y position to 0, right? So we'll just drop them on the top there like that. Let's just type that in there. Y pos 0. Okay, and then we want to copy some spheres onto this. Basically, I didn't explain. So we're going to be, yeah, like I said, fracturing this up. So normally you would make a volume out of this and scatter points into the middle, but you know, this is the surface, the camera's going to be on the surface, so really got to focus our fracturing and detail to the surface. So all of the fracturing, the detailed fracture is going to go on at the top, and then I'll do a lower res fracture at the bottom. Okay, so this will become more clear as we go on. Well, maybe now when I just put these spheres, you can see we're going to scatter spheres all over the surface, and we'll fracture up that top piece, and then the piece underneath will fracture again in a lower resolution, right? So let me set up the scale of this. Is going to be 20, and we're going to want polygon with you know, a lot of frequency, all right, to get it smooth. So let's just look at this fracture as it is now. So geometry in there. Let me just save this in case this is heavy. Well, I'll tell you what, I'll escape that and just do this just 10. There we go. So then it should be a lot faster, and then we can visualize the name attribute. Okay, so you can see there we're getting kind of geometry in the middle, and then it looks a bit uneven. You can see you've got, you know, this, it seems to be more in the center there, right? So I'm going to move this over a bit and move all of the spheres up a bit so I can get that piece at the bottom like I was saying, right? See that? So I'm kind of just clipping off the top there now, which is what I want to do. Okay, so I'm going to come back here, go back to that high res, and then we want to do the same as before. I'm going to peak this geometry. Okay, just a bit. Set that to 4. You can see that. Yeah, you can do this with volumes here. It's okay with the peak. It's obviously not clean, but it's bigger than before, and it should make an okay group. You know, it's not going to be pretty, but it's okay. So we'll do that initial mountain for our big noise. Okay. So I'm going to do 20 for the height. So that looks crazy, like dandelions, and 23. Okay, similar to what we did before. I suppose we do want it to be similar to this because, you know, it's the same fracture really. You know, I'm just subfracturing again. It's the same rock, same material. That's part of the simulation. So let's do this group. I'm going to group everything inside here, so we need this to be on points, bounding region, bounding object, and as you might have guessed, it will be called delete me. And we'll delete that. So the point group and find out delete me. And it will be delete non-selected, of course. Great. And then we get some of these weird kind of points. So just drop a clean node. That's probably a result of this not doing it with the volume, but after getting rid of them, it's fine. You might want to get rid of these kind of floating little pieces, but it doesn't really matter. They should be outside of the geometry later anyway. Okay, so that's good. So what I want to do now, if we look at the fracture again, okay, so what I'm doing here is making our big pieces, our big chunks of rock, right? And what I want to have is what helps to sell a simulation like this is having along the border lots of smaller pieces. Okay, so where these rocks, when this piece falls away, it's going to be grinding along the edge of the other pieces, and you'll get lots of smaller bits along that edge. So the way we're going to do that is to just drop a copy and transform. Okay, and it's not transforming it, but we have got 2 copies. So just to double check, you can see here the number of points. We got 575. Here we should have 287. Yeah. Okay, so we're just doubling up all the points there. You can see when you layer. Well, it's a bit hard to see with all of that, but you'll see with the numbers, you'll have like 2. They're overlapping basically. So we want to add some noise to these pieces again. But the problem is, so when a point occupies the same space as another point, if you add noise to that based on its current position, the noise will be applied in the same way. So you need some kind of seed to push them in different ways. And so what we can use is the connectivity SOP. And that gives us an integer for each connected piece of geometry. So we do want this on the points, yeah. So if we look at that class attribute, we get a different color. And again, they're overlapping, so you won't be able to see them. But they'll be different for each piece, right? So maybe if I drop an exploded view, might see it then. And if we can use the class point. No, still doesn't seem to want to work. Let's see. Now, if we drop an assemble and just do it on the name attribute. Actually, let me get rid of that. No, it's not going to work, but anyway, we'll see it in the next step anyway. So I'm going to drop a attribute VOP. We'll use that class attribute, right? Oh, I know how I can show you. If we just select by the class attribute, if we go into points and select by class, you can see, so I select this, drop a transform. Oh, try that again. There we go. There, and then actually we can just grab the move tool, edit, and just kind of move this. There we go, finally. So you can see they're overlapping there, okay? And we got 2 separate pieces, and the colors are different because the class attribute is not the same. Okay, finally. So like I said, we'll drop an attribute VOP. And this will be, we'll call it debris. It's not really debris, I suppose, like, I don't know, small details. Let's call it that. All right. And then dive inside here. So it'll be similar to what we did before with the turbulent noise. right? So we grab the turbulent, oh, not to type, into position, and cut off that type. And then we're going to add this to our current position. But as I said, you know, they'll be the position, they'll be moved along the same as before, right? The same as each other. So they'll travel in the same direction, if that makes sense. I'm going to try a different noise here, Perlin noise. I'm just going to drop the frequency down to 0.1 again, and give ourselves a good bit of amplitude. Okay, and the way that we get that class attribute is we use a bind. So bind we use to bring in attributes which are not here. We could use them to bring these in, but these are all like binds in themselves, really. So the attribute we want was the one that we just made, which was class. It wasn't a float, it was an integer, and this needs to be put into the offset. And now we get what I was talking about. You start to see, if we come out here, along the borders, we've got lines intersecting each other. So the more of these that we do, the more detail that fracture will be, but it will get heavy very, very quickly, right? There we go. So let's go back and view the name attribute. Let's give this a proper name, fracture. I'm sure we'll be renaming this as we go, so it probably doesn't matter too much, but just to be clean. Okay, so there we go. Like I said, we've got one big piece at the bottom, but on the surface, we've got all these big chunks with interesting borders along the edges, which we will fracture down into, you know, really, you know, we'll subfracture again. These bigger pieces we'll fracture again because they are quite big. But not too much. Okay.